Hey, and welcome to today's video where we will go through some of the questions from the subject of mass and balance, and more specifically the topic of loading of mass and balance. So we have prepared 5 questions where we'll go in depth and in a bit more details as to why, which answers are correct and incorrect, and the general topics. So without any further ado, let's jump into question number 1. And just so you know, all the questions that you'll see have been labeled as the latest ones saw in the latest 30 days across all EASA authorities in the real exams. So it will be a perfect opportunity to see what's new out there. So for question number 1, the performance limited takeoff mass is defined as the. So remember that we will have 2 key masses. So of course our maximum takeoff mass and our performance limited takeoff mass, and the higher of the two, the lower of the two will give us our regulated takeoff mass. The performance limited takeoff mass will comprise of the field limiting takeoff mass, so the length of the runway, the obstacle limiting takeoff mass, so the mass that has to do with our initial climb out and the obstacle clearance close to the airport, and lastly the climb limited takeoff mass, which will have to do with our climb out after the initial segment of our takeoff, so the obstacles further away like the mountains, etc. So for the performance limited takeoff mass, of course, this will be the maximum permissible mass of an airplane at takeoff. However, this is considering that our maximum takeoff weight is bigger than the performance limiting one. In that case, maximum permissible total airplane mass at the start of the takeoff run will be correct, of course, considering that this is within the limitations stated in the aircraft's AFM, so this is something to remember. And for our question number 2, so the total mass limit of a light twin is equal to 3,200 pounds. The pilot weighs 200 pounds and the combined mass of the passengers and their baggage is 850 pounds. Assuming a dry operating mass of 1,742 pounds, how much fuel can be loaded? So this question seems very straightforward and easy. However, there is a little trick or a trap within that I wanted to address. So of course, remember what a dry operating mass is, and this is the key to answering this question. A dry operating mass includes our basic empty mass, BEM, of the aircraft, as well as the variable load. And within the variable load, we have the crew, the water, the meals, etc. And the crew here being the keyword. So the pilot weight of 200 pounds will not be included in our calculations as it's already included within our dry operating mass. And this gives us 850 pounds for the passengers and their baggage, the dry operating mass of 1,742, and this gives us 2,592 pounds. So now if we subtract this from our total mass limit of the aircraft, what we will get is 608 pounds. So if we divide it by 2.2, we'll get our mass in kilograms, which is in this case 276.4. The closest answer, of course, 276 kilograms. Now for question number 3. So the maximum mass to which an airplane can be loaded prior to engine start is. So there is a something that is called our all-up mass, as well as the maximum ramp mass and taxi mass. So actually, these all can be slightly different, and the reason for that is that our AFM of an aircraft will specify a structural limit, that it will be our ramp mass. So this is a mass that the aircraft can actually be stationary with. However, it cannot just yet move. There can also be specified taxi mass, so a mass at which the aircraft can start moving. And depending on the aircraft type, this air mass can be different than our ramp mass, as well as the takeoff mass can also be different than the taxi mass. So our aircraft can be loaded with a certain amount of fuel, it can be moving with a different amount of fuel, and it can also take off with a different amount of fuel as per the limitations go. In that case, the maximum mass which an airplane may be loaded with, so our ramp mass, in this case, will be called the maximum certified taxi ramp mass, and this can be much different than our takeoff mass as well as sometimes the ramp mass can be different than the taxi mass. So these will be always specified in the AFM of an aircraft and always need to be adhered to. And the fuel can be used, for example, during a long wait for the passengers. In case the GPUs are not available, in that case, the APU will burn the excess fuel before the taxi, and then the taxi fuel is used during the taxi in case of long taxi routes towards our takeoff position. And now for question number 4, you have just finished planning a flight and you require 3,643 pounds of fuel. The fuel tanker supplies fuel in US gallons with the specific gravity of 0.84. How many US gallons do you require? And this is a great question because there are 2 ways that you can actually answer it. So of course there is the one, let's say, boring and straightforward way of doing it using the calculator, in which you simply divide the pounds to convert them into fuel by 2.2. We can do this quickly together. In that case, we have the kilograms. Now, if we divide the kilograms by our specific gravity, we can easily get our liters. And in that case, this is 1,971 liters. And of course, then liters to gallons, if we divide it further by 3.785, we will get our answer of 520. However, I wanted to point out here a second method that can come very handy during these exams and that I believe that you should always have in your arsenal whenever needed for some quick calculations. And this is the time where the good old CRP5 can shine again. So as you can see, here on the sides, you'll have a specific gravity section with the pound sign on the outer scale. So all you need to do now is line up your pounds of fuel, in this case 3,600. So we'll go with the inner scale to 36, and you need to put it right below the specific gravity in the specific gravity outer scale. So under 84, we need to put 36. So just like this, you can see, I will try to show you with this arrow right here. Within the specific gravity box, on the outer scale, I have lined up 0.84 with, on the inner scale, 36, representing 3,600 pounds. And all you need to do now is, if you take a look here at the US gallon box, there is a small arrow. So if you read the number below that arrow, you'll see, and I'll try to show you here. So right below that arrow that represents US gallons, you'll actually read our mass in US gallons, which here CRP5 says is 515, which is close enough for any type of question, and it makes for a very quick way to calculate these numbers. And you can go from kilograms to pounds, from gallons to imperial gallons, etc. So this is a quick and good way to make these calculations during your exams, something for you to think about in the future. And now for question number 5, so the last question now we have here for today. So the maximum takeoff mass of an airplane is, and of course the maximum takeoff mass, this is something that is structurally limiting our mass, and the regulated takeoff mass, as we already discussed it, will be the lower one between the maximum and the performance limiting takeoff mass. So this is an important moment to differentiate the two and always state the more limiting one, of course. So the maximum takeoff mass of an airplane will be the maximum permissible total airplane mass at the start of the takeoff run, no matter what. And of course, if the performance limiting mass is more, then we absolutely need to still adhere to the maximum takeoff mass of an airplane, as this is what the aircraft is structurally designed to handle during the loads that an aircraft handles during a takeoff. And of course, this would be the correct answer. So with that in mind, this is everything for the loading topic of mass imbalance. I hope this was helpful, somewhat interesting. Don't forget about the CRP5, as this is a great tool to help you make these calculations and cross-checks during the exams. And as I showed you, this is a very quick and easy way to convert these values, especially in high-stress environment like the exams. So without any more additions, this is everything for today. Thank you so much for watching. I wish you all the best with your upcoming exams. And as always, if you have any questions, feel free to ask. Until the next video, I hope you have a fantastic rest of your day or the week. Bye-bye, and I'll see you next time.